All right, so I have received a few emails and looked over Math Excel at some very common mistakes. So I'm going to try to address everything in this one video. So if you only have one or two specific questions, if you can just hang tight, and hopefully this video will address some issues you may have. So first of all a matrix is it is a rectangular array of numbers. All right, so capital letters represent matrices. Lowercase letters represent elements within the matrices, okay? Now the dimensions of a matrix, it goes row by column, okay? Rows are horizontal and columns are vertical. So this is a column, and that's a column, and this is a row, and that is a row. So this is a 2 by 2. Now matrix B is a 2 by 1, not a 1 by 2, but a 2 by 1, because there are 2 rows and only 1 column. So think about columns are vertical and rows are horizontal, all right? So element A, lowercase a21, would be the second row, first entry, or first column. So that would be the number -1. However, little a, 1, 2, would be the first row, but second column, so that would be element 3, okay? Okay, now why are matrices, why do they even exist, okay? They're not just made up from evil mathematicians to make your life miserable. There is a practical use for these things, mostly in computer science. If you notice that I took the coefficients from this guy here, the number 2, the number 3, the number -1, and the number 1, and I just created matrix A up here above. And then on the right side, this is our matrix B. So it is a nice handy way of ignoring the variables and only considering the coefficients. Okay? Now, matrices are used to solve equations. That's one of the applications here. So this is something you did in Algebra 1 and in Algebra 2, but this is using matrices to solve this equation here. Now, before I show you what an inverse matrix is, let me tell you why matrix or inverse matrices are needed. In the lower right here, if you look at the cloud here, in Algebra 1, you guys were taught to divide both sides by 4 if you were to solve for x, and you get x is equal to 5. Okay? It's also true that you could multiply, instead of dividing by 4, you can multiply by the reciprocal of 4. That's called the multiplicative inverse. So if I multiply both sides by 1/4, 4 times 1/4 is 1, and 1/4 of 20 is 5, okay? So 1/4 is called the inverse, the multiplicative inverse of 4, because 1/4 times 4 is 1, all right? So in other words, we need to find the inverse of this function so we could divide both sides by the coefficients to get our solutions. But the problem is you can't really divide by a matrix, but you can multiply by its inverse, okay? So those of you that are saying inverse functions in this assignment and you're like, where the heck is this coming from? It has to do with this idea here of multiplying both sides by the inverse to solve. Okay, so hopefully I've established the need for an inverse. So here's a shortcut on how to find the inverse function. Some of the problems you encounter, they already give you the inverse, so you don't have to find it, but I'm just going to go ahead and do this all in one fell swoop. So theoretically, if we have a matrix M, we have entries A, B, C, D. This little notation here means inverse. Now there's a little hocus pocus process. Is you take the A and the D and you trade places. So you just switch those two. And the other diagonal, C and B, you just slap a negative on those, okay? So you switch the diagonal, A and D, and then you change the sign of C and B. And then you multiply by 1 over the determinant, okay? Now what the heck is the determinant? The determinant, this is the formula for the determinant. You simply multiply, and I'm going to do this in blue here. You multiply the diagonal, A times D in the upper right. You're going to multiply that diagonal, which is this, and then you're going to subtract the product of the other diagonal, C and B, okay? So here we go. I'm going to find the inverse of matrix A. This is the original matrix A here. So A inverse. I'm going to do my little switcheroo of the diagonals. So I'm going to switch the 1 and the 2. I'm going to switch these two guys, 1 and 2. And then the other two, the other diagonal, I'm just going to change the sign. That's a positive 3, change to a negative 3. This is a negative 1, I'm going to change it to a positive 1. Now I have to multiply by 1 over the determinant, okay, which is this thing here. I have to multiply this matrix by 1 over the determinant. So I'm going to find the determinant of A, and that is 2 times 1. 2 times 1 minus 3 times a negative 1. So that's 2 plus 3, which is 5. So I'm going to take this matrix that I have so far, A inverse, and I'm going to multiply by 1 over 5, because it's 1 over the determinant. 1 over the determinant, upper right-hand corner. So I'm going to distribute 1/5 to every entry in this matrix C here, okay? So 1 times 1/5 is 1/5, negative 3/5, 2/5, and 1/5. Yuck. So that's called the inverse function. Now, let's go back to my original thing here. Now that I have the inverse function, or the inverse matrix C, excuse me, I now can solve this equation. So I'm going to take this guy here, A inverse. So, going back to the original, we have our original thing that we're trying to do. That's the big picture. We're trying to solve this equation. We have matrix A. We have matrix B. I can't divide both sides by matrix A. I have to multiply by the inverse, just like when we multiply 4 times 1/4 to get 1x. This thing will cancel each other. They're just going to wipe each other out. So I'm not going to bother multiplying A inverse times A, because I'm just going to get a 1. I'm just going to get x, or my solution. I'm actually concerned with the right side of this equation. I'm concerned with this, okay? Now here's a real subtle thing here. Notice that, well, first of all, when I multiply 20 times a fourth, that's the same thing as doing 1/4 times 20. Multiplication is commutative, which means the order doesn't matter. Order doesn't matter. However, in matrices, order does matter. This is the counterintuitive thing about matrices, is because it goes against everything you've ever been taught. Here, multiplication doesn't matter. Order doesn't matter. A times B is equal to B times A, but when it comes to matrices, it's not necessarily true. And the reason why is, for you to multiply two matrices, these two middle numbers have to be the same. So notice that 2 is equal to 2. Here, 1 is not equal to 2. Therefore, this is not even possible. Okay? So the reason why I have A inverse on the left-hand side of B is because the order matters. Those of you that try to do this, you won't be able to do it in that order. So, make sure that when you multiply two matrices, that these two middle numbers have to line up. The resultant answer will be the dimensions of the outside numbers. So for example, let me just switch gears here. If we have a matrix C, let's say, that's a 4 by 2. And I multiply that to a matrix D, which is a 2 by 7, okay? I'm just making this up. The 2 matches the 2. The answer will actually be a matrix we'll call matrix E. It will be a 4 by 7. Very strange. Okay, so what I'm going to do now is I'm going to take, to find my answers, I'm going to take matrix A inverse, which I already have here, and I'm going to multiply that to matrix B to get my answer. Okay? Notice I'm going to multiply it on the left-hand side of B for the very same reason that I explained just before. All right, so here we go. I'm going to multiply. So the two middle numbers match. Here's my A inverse on the left. Here's my B on the right. The resultant matrix is going to be a 2 by 1. So here's my answer right here. It's a 2 by 1. So I got a 2 by 1. So 2 rows, 1 column. 2 by 1. All right. Now here's the process on how to multiply. I want this one number here. This one number is the first row, first column. So I'm going to take the first row of the first matrix times the first column of the second matrix. So here we go. I'm going to do 1/5 times 1 plus -3/5 times -3. Okay? So what you're going to do is you're going to take this first element times this element, which is here, and then this element times the second element, which is right here. So this gives me 1/5 plus a negative times a negative is a positive, 9/5, which is 10/5, which is equal to 2. That's the one number that goes in here. So that means that x is equal to 2 in my original problem. Remember, I'm trying to solve for x and y here. All right? Now let me switch to purple here. Dark purple. Now I want this number here. So that is the second row and the second in the first column. So now I'm going to take the second row. Remember, it goes row by column. Second row times the first column here. So 1/5 times 1 plus 2/5 times -3. Getting kind of messy here. 1/5 plus -6/5 is -5/5. -5/5 equals -1. So it has a happy ending even though we have these yucky fraction answers. So the top number is 2. The bottom number is a -1. So here's a crash course on using matrices to solve equations.